In this tutorial, we're going to teach you how to use the Chamfer toolpath. So let's come up to open an existing file, and we'll go for this file here at the top, the Chamfer toolpath guide example number 1, and let's open that up. Now, when it opens up into the software, we can pop over to our 3D view, and you can see here we've got some vectors. We've got in, down, up, and out, down. So to get a better appreciation of what these vectors are going to be doing in conjunction with our Chamfer toolpath, let's head over to the toolpath menu. So let's click on this icon here to go over to the toolpath menu, and the first thing we do is we check our material setup. Now our thickness is 0.5, XY datum is in the bottom left, the Z0 is off the material surface. Now this is really important because with the Chamfer toolpath we'll be machining down from the material surface, so we need to make sure it's at the material surface. Model position and material we don't need to worry about because we're not using a model in this particular project. And the rapid Z gaps above material, these are safe and sound for my machines, but do make sure to double check these for your machine because I have calibrated these with my machine in mind, so do so with yours in mind as well. And the same applies for the Z gap above material. So I'm happy with these settings, and let's click OK. So with our material setup checked, let's go over to our Chamfer toolpath, which is found just over here. So let's click onto that button and let's look at some of the options. Now, the Chamfer toolpath allows you to easily create chamfers using V-bits, bore nose tools, or engraving tools to create decorative edges, and it's also a great way to create countersunk holes. So, in order for us to create a chamfer, we need to select a vector or a series of vectors. So we'll look at this one for now. And while we're in this view, let's actually tile our view so you can see the 2D view as well. So you can see here the direction of the chamfer at the moment going inwards, but let's look at our form. So we've got a start depth, and the start depth is going to be at the top of our material because we want to start from the top and cut down. And the tool in this particular scenario is a V-bit, but we will have a look at creating a chamfer with a bore nose, but we'll look at that a little bit later on. But for now, I'm going to choose a tool. So we're going to come up to the area here where it says tool and click on select. And you can see here that I've got the selection of tools available to me that are in my shop. So these are the ones I've entered into my tool database. Now, in this case, the one I actually want to use is a 60 degrees quarter-inch V-bit, and these settings are all safe and appropriate for my machine, but do double check these before you go running your tool on your machine because they need to be safe and appropriate for your particular setup. But I'm happy with these settings, so I'll click select, and now we can look at the Chamfer Dimensions options. So first up we have the angle, and now you'll notice that that has actually been grayed out. That is actually informing us that this value cannot be changed. That's because we're using a V-bit tool, and so the angle is being pulled from the actual tool itself. So this is why we're seeing 30 degrees in here, because we're using a 60 degrees tool. So the only time this option is available for us to edit is when we're using a bore nose tool, which is when we would need to tell the software which angle we want to cut our chamfer. So next up in the form, we need to calculate our width or cut depth. Now, the values here are actually calculated according to the other. So for example, if we were adamant that we wanted our chamfer to be a total of 0.25 or a quarter-inch width, you notice that the cut depth field there changed. And the same if I change this to 0.5, for example, you'll notice that the other field will change to reflect that. So you can see here that the cut depth is automatically updated for us, and this is based on the angle that we've entered. Another example would be if you want to machine the cut for the full depth of our material. We could enter a cut depth of the thickness of our material. So in this case, if we don't remember what the cut depth is or the full thickness of the material is, you can put in Z equals, and the software will take this from our job dimensions and pull the value of our thickness and put it in here for you. But you can see it's also updated the width field to reflect that value that we put in our cut depth. As the software knows to cut down to this depth, it would need to be this wide based on the angle of our tool. Now the next section of the form we're going to look at is the overcut. Now it's always best to make sure that your tool definitions are correct in your tool database. If for some reason your V-bit or engraving tool has a flat point, you may want to consider using an overcut amount when using a Chamfer toolpath. So the software will run the center of your tool along the line. For example, if your V-bit does not come to a point but has a flat spot at the tip, you will be cutting material away from the inside or outside of the line, seeing as the center of your tool is in the center of the flat area. So what the overcut will do is it will allow you to compensate for that by moving the tool so you can run the edge of the flat along the line, and it will also cut a bit deeper so you will not be left with a step. Now you may want to run a few test parts to ensure that the overcut distance is correct for your tool. So if you want to take a look at adding an overcut of 0.1 for example here, or even a much smaller value of 0.01. Keep an eye on the max cut depth field. You'll notice it changes very slightly. We can delete that out of there for the moment. And the last value here shows us the max cut depth. Now, what this field actually shows us is the max cut depth for the chamfer. Now, this is a read-only field and it shows the full length of the cut, so you can accurately see how deep the tool is cutting. Now, it's important to note that if you're using a V-bit tool, this value will always be exactly the same as the cut depth. If you're using a round tool, then this value is a little bit more than the cut depth specifies, as it has to consider the fact that we're using a rounded tool and has to cut a little bit deeper to achieve the requested width or cut depth entered. But we'll look at that a little bit later in a different example. But as you saw a second ago, that same thing applies if we decide to apply a bit of an overcut, and we'll need to go just slightly deeper in order to achieve the full cut depth. Okay, so next on the form, we need to consider whether we want the chamfer type to be inside or outside. So if you look at the 2D view here, we have an opportunity to choose whether we want to also have that inside or outside cut slope upwards or downwards. And you'll notice when I select these options, it actually reflects on the 2D view. So outside, you can see the arrows pointing outside. Inside, it does the same, and it also reflects it in this form as well. You can see the different views for the different options with upwards and downwards as well, both reflected in the 2D view as well. And a good tip to remember is that the end point or the tip of the arrow here is the deepest point of our chamfer. Now, for our particular example, we're actually going to use the option to slope upwards from the inside, and you can see that what's happening here is the deepest point is at that vector line around the outside here. And you can see that reflected over here with the pink line on this graphic in the Chamfer Toolpath menu. And so what's going to happen is it's going to cut down from that top area, so that's going to remain flat, and it will chamfer down to that area. So we'll leave this as chamfer 1 for the toolpath, and we'll calculate this one. And you'll notice we get a warning to say that we're going to cut through the material, but we already knew we were going to cut through the material. So let's click OK, and let's have a look at our toolpath. Okay, so with our toolpath calculator, let's go into the 3D view fully, and let's right mouse click to drag our view and pan it. And you can see here what's happening is that the tool is going to cut around and then down to where it needs to go with the chamfer toolpath. So let's have a look at that in action. So let's go to the top and the view control here, click preview selected toolpath, and you'll notice here that it's cutting from the top downwards to achieve that chamfered edge. And if I just pan the view here while it's cutting, you can see that chamfered edge coming into view now, and that looks great. So that is our inside sloping upwards chamfer toolpath. But for now, let's tile our views again, and now let's reset our view. And now let's say if you wanted to use this vector again to actually create a profile toolpath to cut this design out for you, you can do that. So you can use the same vector here. So let's go to the profile toolpath, and my start depth is 0, and I'm going to go to the full cut depth on the material. So I'll put in Z equals, so that's 0.5. Quarter inch end mill for this one. Going to cut on the outside of that line. Don't need to worry about these options here. I'm just going to click on calculate, and then we can preview that toolpath, and you'll see that it now goes around and cuts out our chamfer, so we can actually have that as a separate part ready to go, and that looks really nice. So now let's close out our preview and let's look at a different example. So let's go over to this one here in the 2D view. So we've got the in and down example. Let's go over to our chamfer toolpath. We're going to keep all these settings the exact same as we did earlier, but we're going to this time do slope downwards. So let's have a look at what this does. So let's click calculate, and let's have a look at the toolpath. And again, we know we're going to cut through, so that's absolutely fine. So let's click on that, and let's have a look at the preview for it. And here we are. So let's preview that selected toolpath. And you can see how this one has cut down from the vector to the deepest part there. And then what we can think about doing is creating a countersunk hole here, and we can use that for a screw, for example. But the problem is, how do we figure out what the offset needs to be for the pocket toolpath? Well, to do that, we can actually go into the chamfer toolpath, and we can grab this value here, which is the width, and we can right mouse click and copy that. And we can go back over to our design tab, and we'll use this tool here to offset our vectors. Now we're going to offset this one inwards by the value of our chamfer width. So we're going to right mouse click and click paste. Got it set to inwards, and then we can click offset, and that will offset that and create a vector for us that we can now use for our pocket. So if we go over to the toolpath menu again, so let's close down the chamfer toolpath, and with our new vector selected, let's go into the pocket toolpath, and we want to go for the full depth of material. So let's put in Z equals. We don't need the extra tool here, the 1/8 inch, so let's remove that tool. I'm happy with the offset and happy with the file name, so let's click on calculate, and let's have a look at what that looks like. So let's preview that selected toolpath, and you can see how that creates that countersunk hole, which looks great. So you can see how powerful that tool really is. So let's close down our preview. Now, let's say we had a scenario where we don't have a V-bit tool that matches the angle that we want to machine the chamfer at. Well, this is where we could use the bore nose tool instead. So what we're going to do is we're going to choose this vector over here, and we're going to create a new chamfer toolpath again. So let's come up to the right hand side here and click on chamfer toolpath. Now start depth is going to be 0, but we're going to select a new tool. We're going to go into select, and we're going to choose the 1/4 inch bore nose. We're going to select that tool, and now for our angle, we're going to set that to 45. And we want to make sure that our cut depth is the full length of the material, so we'll go for Z equals. And now you'll notice that the max cut depth is just a little bit deeper than our full cut depth. Now this is to help compensate for the round bottom of a bore nose end mill. Having this slightly deeper cut depth will allow us to cut past the cusp of the cutter and give us a nice clean angle at the bottom of our chamfer. So next, let's choose the option for chamfer type. So let's go outside, and we're going to go upwards as indicated by our vector over here. And I'm happy with the toolpath name, so I'm going to click calculate. And again, we get the warning to cut through, but we already knew this. So let's click OK, and let's have a look at what this toolpath is going to look like. So let's preview our visible toolpath. And now let's right mouse click, and let's zoom in a little bit just to have a look at this current toolpath. So as it stands, this isn't exactly smooth, and this comes down to the pass depth of the tool itself. So if we decrease the pass depth, that'll create smaller steps, and the results will be much smoother. So what we can do is close this down. We can go back into our chamfer toolpath. So let's double click on our toolpath, go into edit, and then what we can do is we can change the pass depth field here. So we can put / and then 2 and then equals, so it will divided by 2. So now we get 0.025. Click OK, click calculate to recalculate the toolpath. Click OK for the warning because we know it's going to cut through. And then once this calculates, we can have a look at previewing that toolpath again. So we'll preview that visible toolpath. And this time what you'll notice is you get a much smoother result. You can see it's doing much smaller steps, so you get a much smoother result on that. Now it's also worth noting here that you're unable to create a clearance pass in the chamfer tool. And if this is something that you wanted to do, then you're better off using a molding toolpath. And to learn how to use a molding toolpath, there'll be a guide in the related video section of this tutorial. But for now, what we can do is close out this preview, reset our view, and then we can look at our final example. So let's select the vector we're going to use, which is this inner vector here for the out-down example. I'll explain what the outer vector is in just a moment. Let's go up to the chamfer toolpath, and we're going to choose a different tool. We're going to choose the 1/8 inch bore nose, and this time we're going to double check that our settings are 0.025 because that's what I need in this example. I'm happy with the rest of the settings. Click select. I'm going to change the width to 0.15 and note how the cut depth and the max depth changed to reflect that. I'm going to go outside as explained here and down, and then click calculate, and we can have a look at that toolpath. Let's preview that toolpath, have a look at the chamfer, and you can see how it chamfers down from the top there and creates a lovely looking chamfered edge. And I want to cut this out. Now this is where my outside vector comes into play. Just like earlier, I took the liberty of creating a outside vector for you. So what I did this time is I offset this vector by the width of the chamfer, which is 0.15 if you recall in this form. So I literally took this value and put it into the offset form to offset outwards by to create this vector, and we'll use this one to create our profile toolpath. And we're going to go to the full thickness of the material, 1/4 inch end mill, outside. Don't need to worry about these settings here. Click calculate, And that will now cut outside of that vector line, and we can now cut out our part, and you can see that there's a chamfer on the top here and then a vertical wall at the bottom there. And that covers our 4 examples for the moment. So what we're going to do now is have a look at a real world example, and we're going to use the Chamfer Toolpath to create some countersunk holes for a house sign. So let's go and open that file up, shall we? So let's go up to File and Open, and I'm going to choose the second example here, so the Chamfer Toolpath guide example number 2. Don't need to worry about saving these changes, and we can open this file up and have a look at this real world example. So let's tile our views and let's have a look at what we're working with. We've got some pre-made vectors, and if I pop over to the Toolpath menu, you can see I've got some pre-made toolpaths for our house sign. So let's have a look at these toolpaths in action. You can see this is a VCarve in for the numbers. Let's have a look at that in the preview toolpath form. So let's preview that selected toolpath. Numbers looking nice and sharp, look really great. Let's look at the chamfer toolpath that goes around the outside here. Should give the house sign a lovely effect, and that looks really, really nice. You've got a chamfer going from the top down. Beautiful looking house sign so far. And we want to cut that out. So again, the same logic as we used in the earlier example. Offset this vector outwards. If I just turn that off for a moment so you can see nice and clearly. Offset this vector outwards by the width so you can safely cut this out without affecting the chamfer. So turn on the profile toolpath. Let's have a look at the cutout. And you can see it's cut around it nicely. Nice smooth finish on the edge there. And then finally, we have some drills, and the drills are going to aid us in our countersunk holes, because these will provide the pre-drilled holes that we can then countersink into. So let's preview that, and then we can use that to then screw into our wall. So now just pop this back into top view, and let's just double click the waste material away to get rid of it. Okay, so now we need to have a think about how we're going to create the chamfered edge of these holes. So the idea of having this countersunk edge of the chamfered edge is so that the head of our screw does not stick up proud of the face of our sign. So it creates a bit of a bevel there. So what happens is that the seat of our screw head can nestle in there nice and tight, so it looks flush to the surface. So let's just pop that down to top view. So let's look at toolpath in these, shall we? So let's select our vectors in the 3D view. So let's hold shift while left mouse clicking, and we'll click the other vector as well. Let's go over to the chamfer toolpath, and in this case we want a start depth of 0 because we want it at the material surface. We're actually going to use a 1/4 inch 60 degree V-bit. Let's click select. In this case we want the width to be half of the diameter of the hole, which is 0.25. So in this case it will be 0.25 divided by 2, and then you can hit equals and the software works it out for you, so it does the maths for you. And you notice that the cut depth has been affected as well. Now it will be nice if our V-bit could go over and plunge down to this cut depth and then come back out again and move on to the next hole. Well, we can do that easily just by changing the pass depth of our cutter to the cut depth plus a little bit. So let's go ahead and take a look at our tool setup. If we go to edit up here, and so what we need to do here is we need to go to the pass depth, and what we want to do is we can change that to just slightly over the cut depth. So if we go for 0.217, that's slightly over that, we can click OK, so that's now applied. And what we want to do is go inside, and we want to go downwards. Going to leave the name the absolute same, and I'm just going to click on calculate. And now let's preview that toolpath. So with it selected, let's click on preview, and you can see what it's done there. Create our countersunk holes, and if I actually turn on the toolpath again, I'll show you that it's actually just doing the one plunge for each of the countersunk holes. So that's a pretty efficient toolpath. Okay, so now we're back on our first example, and what we're going to do is actually have a look at some of the options that we didn't look at before in the chamfer toolpath form. So let's go into this first chamfer option here, and you'll notice that we also have the option for the cut direction here. So we have climb and conventional. Now this is down to the way the cutting teeth on the tool engage with the material and the way the chips are removed and deposited. There's plenty of discussion on which is best to use, as one may give you a better finish than the other. Our best advice is to give it a test. If your waste material has a better finish than your actual part, then simply reverse the direction, or in other words, choose the other option. And now we have this option here for use vector selection order. So if I just close this out for a moment, What that's going to do is that if I use that option, it will literally use the vector selection order that I specified here. So let's say I wanted to machine all 4 of these chamfers. But what I wanted to do is do this one, then this one, this one, and then this one. Well, I can do that. So if I literally hold shift and then left mouse click the next one, then left mouse click this one, and then I click this one. If I go to a chamfer toolpath and now I say use vector selection order, what it's going to do is it's going to machine them in the order that I specified there. So let's click on calculate and let's have a look at what that looks like, shall we? So let's close out the preview form for a moment. Let's have a look at this. And if I just actually go back in and reset the preview so you can see it nice and clear, you see it does exactly that. It goes to this one first, up to this one, machines this one, then machines that one. So it did like an N there for that one. And then if you go back into that chamfer toolpath, we have the option here to use the vector selector. Now what we can do with this is use open or close vectors on particular layers, and we can assign toolpaths to a particular layer effectively. So you can have all the closed vectors on, let's say, your up layers, and you can assign them a chamfer toolpath to that particular layer. But we actually cover this in more detail on our other videos. For example, there is a video using job templates which covers how to use a vector selector, so I highly recommend you watch that. But for now, that brings us to a close on our chamfer tutorial, and I hope you have thoroughly enjoyed it, and we look forward to seeing you in the next video.